Today we are going to discuss about the topic vectors. See here vectors is one of the very important topic in physics. Okay, so as you have learned in the previous classes, measuring of physical quantities, what is measurement, what is physical quantity, you have seen earlier. So if you see what is measurement, measurement means the measuring of an unknown quantity with respect to a fixed quantity or known quantity. So that is known as measurement. Then what is a physical quantity? Physical quantity means what? A physical quantity which can be measured is known as a physical quantity. These types of different physical quantities, all these we have learned in our earlier class. Now depends upon the magnitude of the physical quantity, okay, or depends upon those nature how these physical quantities has been classified. Okay, so here based on the nature the physical quantities has been classified into two categories. One is scalar and another one is vector. Okay, so we here the physical quantities has been classified into scalars and vectors. Okay, so here what is a scalar, what is a vector? Scalar represents the physical quantity which is having only the magnitude. The physical quantities which are having only magnitude are known as scalar physical quantities. Is it clear? The physical quantities which are having only the magnitude are known as scalar physical quantities. Then what about vector physical quantities? The physical quantities which are having both magnitude and direction. The physical quantities which are having both magnitude and direction. These physical quantities we will call it as vector physical quantities. Okay. So here if you see in units, we are representing the magnitude of a physical quantity. Magnitude represents what? The value of a physical quantity will represent the magnitude, or simply what we can say, or what we can refer it as the value. Okay, magnitude represents the value. And direction already you know, east, north, south, west, like these directions we can consider. Then here what are the examples of scalar physical quantities? The scalar physical quantity examples, if you consider distance, work, energy, density, pressure, all these will comes under the scalar physical quantities. Means these distance, work, energy, density, pressure will not be having any particular direction. Okay, those physical quantities only we are representing it as scalar physical quantities. Then what about examples of vector physical quantities? See here examples of vector physical quantities. We know very well about displacement. Displacement is a vector physical quantity. Based on this displacement, we will measure velocity. Velocity is also a vector physical quantity. Acceleration is also a vector physical quantity. Why? Because to derive an acceleration, or to derive the acceleration of an object, we will consider the velocity of an object with respect to the time. So velocity we are considering means velocity is a vector physical quantity, then acceleration also will becomes the vector physical quantity. Then force. Suppose if you consider the force, in which particular direction you are applying the force. So these are the some of examples of vector physical quantities: displacement, velocity, acceleration, and force. See here we have seen some of the examples of scalar physical quantities and vector physical quantities. Suppose if you want to show the difference, how can we understand with an example, easy example, how can we understand the difference between scalar and vector? So if you consider an example, suppose a person is coming from somewhere from Mumbai to Kovilpatti, or somewhere from Mumbai to Hyderabad, if the person is coming. So after getting down the train, if he make a call and ask you what is the distance from your home to the railway station, simply what we will answer, we will say some 5 kilometers. Here what question he is posing means, he is asking alone how much distance is there in between the railway station to the home. But the another person has asked how to come to your home. Then how to come to home means what we will say or what we will answer. See, if the person is coming from railway station to our home, we will guide each and every landmark, means come towards 100 meters forward direction and then take left and then take right, there you can find a pole. Like that we will represent some particular directions. So those direction representation will comes under vector physical quantities. And one more difference what we can say about the scalars and vectors. See here, the scalars or the scalar physical quantities will follows the normal algebra, whatever we are following, addition, subtraction, multiplication, division. But here, whenever it comes to the vector physical quantities, means directional physical quantities, those will follows vector algebra. Even in vectors also, we will be having vector addition, vector subtraction, vectors multiplication, and vectors division. Okay, in that mainly we will further classes we will going to see about what is the vector algebra. Okay, how to represent the vector physical quantity. So first of all, if you consider in mass, we will get the line segment. What is line segment? The line joining of 2 points. Suppose if I consider A and B are the 2 points, and the line joining of 2 points we will consider it as a line segment. Okay, suppose if it is directed, means what? If it is a person is moving from A to B or B to A, like that, if you are representing with the direction, this we will call it as directed line segment. Okay, see here, if the person is moving from A to B, this directed line segment can be written as AB bar. Suppose if the person is coming from B to A, then this directed line segment can be written as BA bar. The same way, how we are considering for directed line segment, we will represent a vector with the same line segment process. See here, every physical quantity or the vector physical quantity will be represented as an alphabet overheaded with an arrow. Here, alphabet is used to represent the magnitude, and this arrow mark is used to represent the direction. Suppose if you consider AB, the length we will consider it as the magnitude, and this directed arrow mark will be represents the direction of that particular person movement. Okay, so here this can be written as if you write modulus of AB bar, means here it will gives modulus of AB bar will gives the length of the vector. Length of the vector. So here, instead of that A bar, if you are writing AB, so here AB will represent the magnitude or the length of the line segment, and this arrow is used to represent the direction. Okay, this is the representation of a vector. Every vector or vector quantity is represented with an arrow overheaded with the alphabet. Okay, and if you want to write in terms of letters, that vector quantity should be represented in bold letters, B bar, or else if you want to write A bar vector. If you want to write C bar vector. The same way, if you consider force, F bar. If you consider the velocity, V bar. If you consider acceleration, A bar. If you consider displacement, T bar or S bar, we can represent with. This is a representation of a vector physical quantity. Different types of vectors. Okay, even in vectors are also we will be having different types of vectors like vectors or parallel vectors, unlike vectors or anti-parallel vectors, equal vectors or opposite vectors, unit vector, null vector. Like this, in vector quantities are also we will be having number of types of vectors. So here first one, if you see like vectors, what are like vectors, or this can be called as parallel vectors. Parallel vectors. So what are like vectors or parallel vectors? Quantities which are having same direction and magnitude may be different, those vectors we will call it as like vectors or parallel vectors. Suppose if you consider a person is running along a straight road towards east direction, and he traveled some 5 meters, and another person B is running along same east direction, but he has covered 6 meters. If you observe this one, A and B, both the persons are running along east direction, but how much magnitude they have covered means how much distance they have covered. Here A person has covered 5-meter distance, and B person has covered 6-meter distance. Means what? So here the direction is same, but magnitude is differs, or magnitude is different. This type of vector quantities we will call it as like vectors or parallel vectors. Okay, the physical quantities which are having same direction but magnitude may be different, those vectors we will call it as like vectors or parallel vectors. From this we can easily understand what are unlike vectors or anti-parallel vectors. See here, unlike vectors are anti-parallel vectors. So here, unlike vectors or anti-parallel vectors, what we can say, the physical quantities which are having opposite in direction and magnitude may be different. These physical quantities we can consider it as unlike vectors or anti-parallel vectors. The physical quantities which differs in direction and magnitude may be different, those physical quantities we will consider it as unlike vectors or anti-parallel vectors. If you see an example, a person A is running along a straight road towards east direction, and he has covered 5 meters. Another person B is running towards west direction, and he has covered some 6 meters. Okay, then if you observe these two, what we can say, A is running along east direction, B is running along west direction, and if you observe this one, 5 meter A has covered, 6 meter B has covered, means whatever the distances those A and B has covered, that are different, and the direction is also different. Like this physical quantities we will consider it as unlike vectors or anti-parallel vectors. Then next one, equal vectors. Equal vectors. What are equal vectors? The name itself, equal. Suppose if you consider 2 is equal to 2, means 2 is equal to 2 alone, right? So the same way, if you consider equal vectors, suppose if you consider two persons A and B. A person A is running along east direction 5 meter, he has covered. Then another person B, he has also covered 5 meters along east direction. Looking at these two arrows, what we can observe, A person and B person both has covered 5 meter distance, and both are running along east direction. Means what? Direction is same and magnitude is also same. Means the physical quantities or the vector physical quantities which are having both magnitude and direction are same, those physical quantities or those vector physical quantities we can represent it as equal vectors. Okay. A person, B person both are traveling or running along the east direction and both are covering equal distances or both has covered equal distances. So these type of vectors we will call it as equal vectors. The vectors which are having both magnitude and direction, those we will call it as equal vectors. Then what are opposite vectors? Opposite vectors, or this can be called as negative vectors. Okay, opposite vectors are negative vectors. See here, vector quantities which are having same magnitude but opposite in direction. Opposite in direction. Those vector quantities we will call it as opposite vectors. See, observe the person A is running along east direction and he has covered 5 meters. But the person B is running along west direction, he has covered the same 5 meters. If you observe, A and B both are running opposite each other, but they are covering the same distance. These type of vectors we will call it as opposite vectors or negative vectors. The vectors which are having same magnitude but opposite in direction are called as negative vectors. See, types of vectors we have learned, like vectors or parallel vectors. The vectors which are having same direction but different magnitude we will call as like vectors or parallel vectors. And unlike vectors are anti-parallel vectors. The vectors which are opposite in direction and magnitude may be different. Those vectors we will call it as unlike vectors or anti-parallel vectors. And equal vectors, the vectors which are having same magnitude and same direction, then these vectors we will call it as equal vectors. And opposite vectors, the vectors which are opposite in direction, magnitude must be equal. Those vectors we will call it as opposite vectors. And here you can observe a difference, equal vectors and opposite vectors. If you have considered the equal vectors are the part of like vectors. Equal vectors are the part of like vectors. Why? Because in like vectors what we are representing, magnitude may be same or may be different, like that we are representing, right? So equal vectors will come under like vectors. The same way if you consider opposite vectors will come under unlike vectors. Okay, here magnitude may be different, like that we are representing. So equal vectors are part of like vectors, opposite vectors are the part of unlike vectors. And the fifth type of vector is unit vector. See, in vectors, unit vector is very important one. Why? Because these unit vectors are used to represent the direction of a physical quantity. Okay, these unit vectors are used to represent the direction of a physical quantity along the coordinate axis, x-axis, y-axis, z-axis, like that. Okay, and what is a unit vector? The vector which is having the magnitude 1 is called as a unit vector. As we have told, representation of vector. Suppose if you consider a vector a bar. So if you consider a vector a bar, vector will be having both magnitude and direction. Then here a bar modulus will represent the magnitude and direction. How can we represent the direction of a vector? By making the use of a unit vector. And these unit vectors are represented with a cap overheaded with an alphabet. So here, if I am writing a unit vector, this can be called as a cap or a hat. So these unit vectors are used to represent the direction, right? So this is the magnitude, then direction is what? A cap. Suppose if I want to write the b bar vector, b bar is equal to modulus of b bar magnitude, and b cap is used to represent the direction. From this a bar and b bar, how can we write a unit vector of a bar and a unit vector of b bar? Okay, see, if you consider a bar vector, a bar is equal to modulus of a bar and A cap. This is the representation of a vector. This is vector. Vector will be having both magnitude and direction. Modulus of A bar will represent the magnitude and A cap is used to represent the direction. So modulus of A bar into A cap. Then here we require unit vector alone. If you want A cap alone means what we need to do? We need to send modulus of A bar to the LHS side. Then if we send A bar by modulus of A bar is equal to A cap. So here we can rewrite this one as A cap is equal to A bar by modulus of A bar. So the unit vector along A bar vector is known as A cap is equal to A bar by modulus of B bar. The same way we write for B bar is equal to modulus of B bar and B cap. Then B cap can be written as B bar by modulus of B bar. So the unit vector along B bar vector is given as B cap is equal to B bar by modulus of B bar. See, some of the students may get doubt, sir. Suppose here A bar and B bar two individual vectors we are having. Then if they are adding or subtracting, how can we consider those unit vectors? See here, if I write A bar plus B bar, the addition of two vectors if I am doing A bar plus B bar, for this the magnitude is what? Modulus of A bar plus B bar. This is magnitude. Okay, modulus, before we have discussed it, right? Modulus will give the magnitude of the vector or the length of the vector. So modulus of A bar plus B bar. Then direction, how can we represent? Suppose if it is A bar, we have represented with A cap. Suppose if it is B bar, we have represented with B cap. But here A bar plus B bar both we are having. Then how can we represent? See, any other letter we can consider and we can make it the unit vector of A bar plus B bar. So for example, if I consider n cap is the unit vector along A bar plus B bar. And here unit vector can be written as n cap is equal to A bar plus B bar divided by modulus of A bar plus B bar. Okay, this is about the unit vector. The vector which is having magnitude 1 is called a unit vector. And what is the use of unit vector? These unit vectors are used to represent the direction along x-axis, y-axis and z-axis. And here the unit vector is represented with a cap or hat overheaded with an alphabet. A cap. This can be pronounced as A cap or A hat. Usually we will represent with A cap. So here if we consider a vector will be having both magnitude and direction. So magnitude of A bar vector is modulus of A bar and direction can be represented with A cap. And for this A bar, the unit vector can be written as A cap is equal to A bar by modulus of A bar. So the sixth one is zero vector. Zero vector. The vector whose magnitude is equal to 0 is known as zero vector. The vector whose magnitude is equal to 0 are known as zero vectors. So if you consider the modulus of A bar, if I consider a vector A bar, the modulus of A is equal to 0, these we will call it as zero vectors. If you consider a person is traveling from A to B and he has covered a distance of 5 meters, and again the same person is traveling from B to A, then the same 5 meter distance in return he has covered. Then the total distance covered by the person is equal to 5 plus 5 meter, that is equal to 10 meters. But whenever it comes to the displacement, the initial point is A and the final point is also A. If the initial and final points are same, then what is the displacement? The displacement will be equal to G. So if you consider the displacement vector for a round train, the magnitude is becoming 0. So those vectors we will call it as 0 vectors. Or else, suppose if you consider a person is running along a circular path and he has started at A, and for one complete revolution the distance is equal to 2 pi r. Distance is equal to 2 pi r. Distance is a scalar quantity which is not having any particular direction. Then if you come to the displacement, the displacement traveled by the person is equal to 0. Why? Because the initial and final positions are same. Then the magnitude becomes 0. So these type of vectors are known as 0 vectors. Okay, and their direction is undetermined or arbitrary. Okay, the direction of 0 vector is undetermined and the magnitude is equal to 0. Okay, this we will call it as 0 vectors. Then next one, co-initial vectors and co-terminal vectors and coplanar vectors, non-coplanar vectors. So here, as we have discussed in the representation of a vector will be having the initial point and the terminal point, and we have represented those as a tail and head. So the vectors which are having the same initial points are known as co-initial vectors. A bar, B bar and C bar. A bar, B bar, C bar are starting from the same point. So these type of vectors we will call as co-initial vectors. The vectors whose origin is same, those vectors we will call as co-initial vectors. And co-terminal vectors. So that name itself will represent terminate. So stopping point. The vectors whose terminating point is same, those vectors we will call it as co-terminal vectors. The vectors whose terminating point is the same are known as co-terminal vectors. A bar, B bar, C bar are the vectors which are terminating at a particular point O. These we will call it as co-terminal vectors. Then what about coplanar vectors? Coplane. If you consider a plane A, B, C, D. If you consider a plane A, B, C, D. The vectors which are lying on the ABCD plane or the vectors which are lying on the same plane are called as coplanar vectors. Suppose if I consider a vector A bar, B bar, it may be of any direction, C bar and D bar. If you come across A bar, B bar, C bar and D bar, these all four vectors are sharing the same plane. So those vectors we will call it as coplanar vectors. The vectors which are lying on the same plane are represented as coplanar vectors. Then what about non-coplanar vectors? If we consider two different planes A, B, C, D and another different plane P, Q, R, S. Here ABCD plane we are having vectors A bar and B bar. And here PQRS plane vector C bar and another vector D bar. So whenever it comes to ABCD, A bar and B bar are coplanar. Whenever it comes to PQRS, C bar and D bar are coplanar vectors. But A bar, C bar, D bar, all these together will come under non-coplanar vectors. Why? Because A bar, B bar are lying on one different plane and C bar or D bar are lying on another different plane. So like this vectors we will call it as non-coplanar vectors. What is the difference between coplanar and non-coplanar is the vectors which are lying on the same plane are called as coplanar vectors. The vectors which are lying on different planes we will call it as non-coplanar vectors. Okay, this is about co-initial, co-terminal, coplanar and non-coplanar vectors. Proper vector.
So here, why what we can say, it is a proper represents the magnitude which is not equal to 0. Those vectors we will call it as proper vectors. The vectors whose magnitude is not equal to 0 are called as proper vectors. Means having some magnitude, those vectors we will call it as proper vectors. See, if I consider a bar is a vector, then modulus of a bar is not equal to 0. These type of vectors we will call it as proper vectors. Here modulus of a means what? Magnitude. The magnitude of a bar is not equal to 0. Those type of vectors we will call it as proper vectors. Then free vectors. What are free vectors? The vectors which can change or which can displace from one place to another place without changing the magnitude and direction. Those vectors we can call it as free vectors. The advantage in vectors concept is a vector can change its position from one place to another place, or it can displace from one position to another position without changing the magnitude and direction. So if I consider a vector a bar, which is having some 5 meters moving in one particular direction, this vector a bar I can displace from this position to another position. Suppose if I displace from here to here without changing the magnitude and direction, there is no change in the vector. Or else, suppose here I can displace like this also, a bar, without changing the magnitude and direction. The same direction, this a bar is also moving, and the same magnitude this is also having. So these type of vectors we will call it as free vectors. Okay, proper vector means whose magnitude is not equal to 0. Those we will call it as proper vector. Free vectors, the vector which can displace from one place to another place without changing the magnitude and direction. Those we will call it as free vectors. Position vector. So if you want to represent a position vector, then what we require? We will consider the Cartesian coordinate system to find out the position vector. Here, the Cartesian coordinate system is very convenient to find out the position of the vector. So here, Cartesian coordinate system means x-axis, y-axis, negative x-axis, negative y-axis. So here, if you want to specify the position of a vector, what we will consider? We will consider the fixed point. Suppose with respect to the origin, if I am considering my fixed point, and there is a point x comma y. The line joining of this origin to this point represents the position vector. Suppose if I consider r bar, the position vector of xy is r bar. Okay, position vector will represent the position of the object with respect to the fixed reference point. If you want to check whether an object is at rest or motion, we will consider a reference point, means a fixed point to check whether an object is in rest or motion. Like that same way, here we will consider a fixed reference point to specify the position of the object. Okay, so this will represent it as position vector. Okay, then what are orthogonal vectors? Orthogonal vectors. The vectors which are mutually perpendicular to each other are known as orthogonal vectors. Or the angle between any two vectors is equal to 90 degrees. Those vectors are also, we can consider it as orthogonal vectors. Okay, so here the vectors the angle between those two vectors will be is equal to 90 degrees, or the vectors which are mutually perpendicular to each other, we will consider it as orthogonal unit vectors. Suppose if you consider this book here, horizontal line if you consider it as x, and vertical direction if you consider it as y, the angle between these horizontal and vertical will be is equal to 90 degrees. So x axis x bar and y axis y bar, these two are mutually perpendicular. These can be called as orthogonal vectors. So if we consider the corner of the room, see, corner of the room, it will be having some length, some breadth and some height. So x axis, y axis and z axis, like that if we consider, so those three are mutually perpendicular to each other. See, observe here, if you consider, this one is outward direction will represent the z axis, x axis, y axis, z axis. See, this is one corner and this is another side and this is another side. Then x axis is mutually perpendicular to y axis is mutually perpendicular to z, and this z axis is mutually perpendicular to x. These type of vectors we will call it as orthogonal vectors. Then next one, orthogonal unit vectors. Orthogonal unit vectors. So here, as we have seen, unit vectors are used to represent the direction along a vector. So orthogonal unit vectors means in the Cartesian coordinate system, if we consider x axis, y axis and z axis are mutually perpendicular to each other. Okay, so those axis if we consider as vectors x bar, y bar and z bar. Along the x bar, along the y bar and along the z bar, there are some unit vectors to specify the direction. Those vectors we will call it as orthogonal unit vectors. Along x bar, the unit vector is I cap. Along y bar, the unit vector is j cap, and along z bar, the unit vector is k cap. Here I cap, j cap and k cap are used to represent the direction along x axis, y axis and z axis. By making use of these orthogonal unit vectors, we will specify the position of a vector by using these I cap, j cap and k cap. See, previously we have seen there is a point x comma y. So how can we represent this r bar vector? Means r bar is equal to, so here two points we are having, x, y point. So here x, along the x axis the magnitude is x, then direction is what? Direction is represented with I cap. So x I cap plus, then y point is also there, right? Y, then along the y direction the unit vector is j cap. So r bar is equal to x I cap plus y j cap. Suppose if they have given a point 3 comma 5, if they have given a point 3 comma 5, how can we represent a vector? Is r bar is equal to, this represent x value and 5 represents y value. Then in the place of x and y, substitute that one. Here 3 I cap plus 5 j cap. See, this is a representation of a vector whenever they have given a particular point. Here position vector, to check the position of a object with respect to the fixed point, we will represent this one as a Cartesian coordinate system. We will represent in terms of Cartesian coordinate system to find out the position vector. And orthogonal vectors, the vectors which are mutually perpendicular to each other, we will represent it as orthogonal vectors. And orthogonal unit vectors, the vectors which are mutually perpendicular to each other. Along that mutually perpendicular vectors, there will be some specific directions to represent. Those specific directions will be represented with unit vectors I cap, j cap, and k cap. As we have seen, cap is used to represent a unit vector. I cap is a unit vector, j cap is a unit vector, k cap is a unit vector. Then, by making use of the given point, how can we write the position vector? Suppose if they have given x comma y, then the vector can be written as xi cap plus yj cap, and here 3 comma 5 they have given, then 3 I cap plus 5 j cap, x component and y component. Like that we will see one more example, then we can understand it very clearly how to represent the position vector. Suppose one more z point is also adding here, means then suppose if we consider x comma y comma z, then this representation is xi cap plus yj cap plus z k cap. Here x, y and z are the magnitudes along x axis, y axis, z axis, and I cap, j cap, k cap are used to represent the direction along x axis, y axis and z axis. Suppose if the object is changing its position from origin to some -5 comma 2, this is x component and this is y component, then vector can be represented as r bar is equal to -5 I cap. Along with the sign we will write -5 I cap plus 2 j cap. -5 I cap plus 2 j cap. Then how can we find the magnitude of this r bar vector? How can we find the magnitude of this r bar vector? See here, this magnitude means modulus alone, right? Modulus of r bar means root over -5 whole square plus 2 whole square. That is equal to root over 25 plus 4, that is equal to root 29. So the vector representation for -5 comma 2 point is -5 I cap plus 2 j cap. Then how can we find the magnitude of this given vector is modulus of r bar, that is equal to root over -5 whole square plus 2 square, that is 25 plus 4, that is equal to 29. And here r bar is equal to x I cap plus y j cap. Then modulus of r bar can be written as modulus of r bar is equal to root over x square plus y square. R bar vector is xi cap plus yj cap. Then modulus of r bar can be written as root over x square plus y square. Suppose if it is having third dimension, xi cap plus yj cap plus z k cap, then modulus of r bar can be written as root over x square plus y square plus z square. Okay, root over x square plus y square plus z square. See, I will explain with you one simple thing, how to find the displacement of an object. You know very well how to find out the displacement of an object. See, this is for x, y, z, this is x comma y. Whenever they have given the points, the vector representation xi cap plus yj cap, xi cap plus yj cap plus zk cap. X and y are used to represent the magnitude and I, j are used to represent the direction, specify the direction. Then here a person is traveling from A to B and then B to C. Here A to B the distance is x and B to C the distance is y. With respect to Cartesian coordinate system, if I specify x axis and this is y axis, then this point is what? This is x and along this y. So this point C is x comma y. The actual distance is what? X plus y. What is the displacement if I ask? What we will do? By applying the Pythagoras theorem. Here, this will be the shortest path which is used to represent AC, the displacement. So here AC can be find out by using the Pythagoras theorem. AC square is equal to AB square plus BC square. Then here AC square is equal to, what is the value of AB? X square. What is the value of BC? Y square. Then AC is equal to root over x square plus y square. So here, if I consider this one is R bar, then this will be the magnitude of R. Modulus of R bar can be written as root over x square plus y square. A person is moving towards east direction and then start moving towards the north direction. Then what is the displacement means we can find out very easily by applying the Pythagoras theorem. But if they have given from the final point he is climbing a pole of some distance, then one more dimension is added, right? That is z dimension. So that time we will get it as R bar is equal to xi plus yj plus zk. So whenever the third dimension has come means the magnitude will become what? Magnitude of R bar is equal to root over x square plus y square plus z square. This is the representation of the position vector. How to write the position vector for a given point is by making use of R bar is equal to xi cap plus yj cap. And xyz, three dimensions if they have given, x axis point, y axis point and z axis point if they have given, this can be written as xi cap plus yj cap plus zk cap.